Alright, in this section we're going to be looking at the limit theory that was discovered by Sir Isaac Newton. It's a helpful theory because as opposed to quadratic theory, it applies to multiple different types of functions. Quadratic theory, remember, only applies to quadratic or reciprocal functions, whereas limit theory, we can apply it to whatever we like. So let's take as an example here the parent function of a quadratic, y equals x squared. And we'll go with our same two basic points, the point 1, 1, we'll call this f. And then we pick a point that's relatively close to point f, we'll call that point m. And this point now is going to be 1 plus h. And then it's going to be, from here, it's going to be 1 plus h squared. Now the idea behind the limit theory is that I have two pieces, so I have my tangent at point 1, 1, and then I have a segment, we'll call this segment FM. And as of right now, these two, the segment FM and the tangent at point 1, 1, have very different slopes. However, as I take point M, and I move it along the parent function closer and closer, but not equal to point F, the slope of FM is going to get closer and closer to the slope of the tangent at point 1, 1. So the idea is that if we keep moving M closer and closer, then we should be able to use this theory to find the tangent, the gradient of the tangent. So let's look at how we would do that. So let's take our same old slope formula, which is y2 minus y1. And then from here, we're just going to plug in what we know. Well, y2 is 1 plus h squared minus 1 plus, no, that's not correct. Let me back up just a second here. Okay, so there we go. Now we got it. So 1 minus 1, so here's our y2 and our y1, over x2, which is 1 plus h minus 1. And when we simplify this a little bit, we should be able to come closer to an answer. So 1 plus h squared will give us 1 plus 2h plus h squared minus 1 over, we can go ahead and cancel these out, and so we're left with just h. Also, our 1's cancel out, so we have 2h plus h squared over h. Let's factor out an h, and we're left with 2 plus h. This is helpful because then we can cancel out this h, and we're left with the limit as h approaches 0, which means, so h is the only difference here between point F and point M. So we took the x value of point F and we added h, whatever that is to us, depends on what point we chose on the line. And so the limit as h approaches 0 of 2 plus h. So then, hypothetically, if h is 0, then we're left with 2 plus 0. So 2 is actually going to be our gradient of the tangent at point 1, 1. Again, we can't plug in 0 for h because then we would just have the same value, and we would also end up with well, what would happen here if we plugged in 0 for h? Well, it would be undefined, so you can't divide by 0. So we can't, but hypothetically, so on the graph, right, it would be a hole there, but hypothetically, if we could, then it would come out to be 2. So those are the basics of the limit theory. Now, let's look at the next piece on this. So if we want to generalize things a little bit more, so we could use this as our basis to work from. So here's the parent function, and my graph is a little bit off, but I'm sure you guys will excuse that. So here's 1, 1 again, and then here's our point M, which we said was 1 plus h, and 1 plus h squared. So now if we generalize this a little bit more, again, let's rewrite f, and we're going to rewrite this as x and the function of x. Now let's go up here and let's rewrite this one as well. So let's make this, what will we make this? Let's make this x plus 1. And then this one will be x plus, sorry, not x plus 1. I'm goofing up again. So this will be x plus h, and then this one will be the function of x plus h. So then we take that and plug it back in. So this should be helpful to you guys. So what we end up with ultimately is we end up with a general rule that can be followed. So we want to find the gradient of the tangent to the curve y equals f of x. Well, let's go ahead and work this out just a little bit. So if we have f of x plus h, this is just using our slope formula, minus f of x over x plus h minus x. Well, from this, let's see, what can we do? Well, we can go ahead and we can leave it like this on in the numerator. That's good. But down here, we can go ahead and cross this out. So we actually end up with a function of x plus h minus f of x over h. Now, if you want to generalize this a little bit more, you could do something that looks like this, f of, which I think is what your book shows, f of a plus h minus f of a, but it's the same thing, so it doesn't really matter. So here it is. Okay, and you can move on if you would like to, and you can use this to find the gradient of the tangent to the parent function f of x equals x squared at the point 2, 4. Now the only difference here that we're going to see, excuse me, so we don't have to graph it at this point. We should be able to do this. Our f value is 2, 4, and that means that our m value is going to be, for m, we're going to plug in 2 plus whatever h is. And now we're going to take 2 plus h, because remember, this right here is the function of x, so we took x, which is 2, and we plugged it in here, and that's 2 squared, and that popped out and gave us this. So we do the same thing, we take 2 plus h, and we plug it into our function, and we end up with 2 plus h squared. Okay, so now we just use our slope formula, and we're going to end up with 2 plus h squared. And at this point, if you guys have this down, you can turn me off here and continue on with your homework or something. But hopefully it's a good review. So 2 plus h squared minus what? Minus 4 over 2 plus h minus 2. So work this out. 2 plus h squared will give you 4 plus 4h plus h squared minus 4 over 2 plus h minus 2. And these will cancel out, as will these. We can also factor out an h. So when we factor out an h, we are left with 4 plus h over, and what's left on the denominator is just h. Well, the cool thing here is that h and h will cancel out, so we're left with the limit as h approaches 0 of 4 plus h, that should be a 4 right there, equals 4, because again we can't plug in h. If we plug in, or 0, excuse me, if we plug in 0, we're going to end up with something that is undefined. But hypothetically, what is the behavior at this point if 0 was feasible? Well, it would be 4.